In section 3.5, we're going to work with multiple angle formulas. We're going to work with power reducing formulas. We're going to use half angle formulas. And we're going to use product to sum and sum to product formulas to rewrite and evaluate trigonometric functions. And we're also going to, of course, use trigonometric formulas to rewrite real-life models. So when we start looking at multiple angle formulas, we're going to look at functions with multiple angles, squares of trigonometric functions, functions of half angles, and products of trig functions. So we're going to work with all of these guys in this section. So these are our double angle formulas. So you see that we have them for sine, for cosine, and for tangent. And we're going to start here with solving a multiple angle equation. So if I look at cosine of 2x, that's going to be cosine squared x minus sine squared x plus cosine of x equals 0. And if we look at sine squared x, right, we will remember that sine squared x plus cosine squared x equals 1. So sine squared x would be equal to 1 minus cosine squared x. Okay, so now I've substituted, right, in this case sine squared x would be equal to 1 minus cosine squared x. And I substituted that in here, so I'll have cosine minus negative cosine squared would be 2 cosine squared. And we're going to have plus cosine x minus 1, and that's going to equal 0. So if we want to look now at continuing to solve this, I would want to factor this. I've made it a quadratic function. My initial problem was that I had sine squared in it, and I converted that to be cosine squared and the 1. And now I want factors of these that are going to equal 0. So I know that I'm going to have cosine x plus something and cosine x minus something, and the factors of 1 are 1 and 1, so that's the way it's going to go. And I know I want products of these factors that are going to have a difference of positive 1. So if I have 2 times 1 is 2 and 1 times 1 is 1, they have a difference of 1. The 2 is going to have to be positive, so I put that here. So my insides and outsides are going to be 2 cosine x, and my outside will be negative cosine x, and 2 minus 1 would be positive 1. Right now, if we want to continue on to solve, I'd set them both to be equal to 0. Cosine x plus 1 equals 0. So that would be cosine x equals negative 1. And going back to the unit circle, where is the x-coordinate, right? Cosine would be the x-coordinate, negative 1. It's over here at negative 1, 0. So that would be pi. X is equal to pi. And over here, 2 cosine x minus 1 equals 0. So cosine of x would equal, add 1 divided by 2, that would be 1/2. So where is cosine 1/2? Where's the x-coordinate 1/2? That would be here and here. Okay, so this would be 60 degrees, or pi over 3. So it would be pi over 3. And then down here would be 5 pi over 3. And of course they're going to be plus and minus 2 pi n. Plus and minus 2 pi n. Plus and minus 2 pi n. So that accounts for all the coterminal angles to these. Okay, let's look at another problem. So use the following to find the sine of 2 times theta, the cosine of 2 times theta, and the tangent of 2 times theta. Okay. So if I wanted to rewrite this, sine of theta equals 3/5. So if I take my values here for sine, this would of course be the side opposite and the hypotenuse. And it tells me between 0 and pi over 2, so that's here in quadrant 1. I know my y-coordinate is 1, 2, 3, and my hypotenuse is going to be 5, and that means that my x-coordinate must be 4. Okay, because this is a 3, 4, 5 right triangle. I might have used the Pythagorean theorem to come up with 4, but that wasn't really necessary. Now, if I take a look at now finding the double angle information, let's go ahead and pull these rules and bring them over just to make it a little easier. So if I would like to find the sine of 2 theta, it's going to be 2 times the sine of theta, which is 3/5, times the cosine of theta, which would be 4/5. So I'll have 2 times 3 is 6, times 4 is 24, over 5 times 5, which would be 25. If I want to find cosine of 2 theta, that's going to be cosine squared. So cosine was 4/5 again, so I'll have 4/5 squared minus sine squared, which would be 3/5. So 16 25ths minus 9 25ths. 16 minus 9 is 7 25ths. And finally, if I want to do tangent of 2 theta, that's going to be 2 times the tangent of theta. So that's 2 times opposite over adjacent is 3/4 over 1 minus tangent squared, which would be 3/4 squared. So up in the numerator, I'll have 6/4. And down here, I'll have 1 minus 9/16. Well, 1 is 16/16. Minus 9/16 is 7/16. And 6/4 is 3/2. And the last thing I'd want to do then is I'd want to invert and multiply. So I'll have 3/2 times, I invert this, 16 over 7. This cancels out to be 8, and I'll get 24/7. So I could start off by writing this as cosine of 2x plus x, which will allow me then to use the sum formula that I have down here, which will make this the cosine of 2x times the cosine of x minus the sine of 2x times the sine of x. So I could start there. And then I have the double angle formula that I can use for cosine of 2x. So this will become cosine squared x minus sine squared x times cosine of x minus sine of 2x times sine of x. So I might use the double angle formula for this as well. So sine of 2u is 2 sine of u times cosine of u. So this will become 2 times sine x cosine x times the sine of x. Okay, if we want to go ahead and start simplifying some of these things, I know that sine squared x is going to be 1 minus cosine squared x. And if I go ahead and just multiply in my sine of x, this is going to be 2 times sine squared x times cosine of x. And that's also going to be 1 minus cosine squared x. And if we go ahead and multiply these things across, let's go ahead and distribute the, well, let's simplify in here. We have cosine minus negative cosine. That's 2 cosine squared x minus 1 times cosine of x. And over here we'll get, if I go ahead and distribute this, I'll have 2 cosine cubed x minus cosine of x. And that's going to be minus, here we'll have 2, actually let's go ahead and we're going to multiply 2 cosine onto all of these things. We'll have 2 cosine x, and we'll have 2 times minus 2 cosine x times cosine squared x. That's going to be minus 2 cosine cubed x. And if I start working with my right, so this is minus 2 times, I'm sorry. And if I go ahead and simplify this now, I'll have 2 cosine squared x, sorry, cubed x, minus cosine of x, minus 2 cosine x plus 2 cosine cubed x. So I'll have 4 cosine cubed x minus 3 cosine of x. And that's complete. So if we take a look here at our power reducing formulas, so we can use these rewritings of the double angle formulas in order to go from sine, cosine, or tangent squared and bring it down to something that's not squared. And you'll notice they're all in terms of cosine, so that might be helpful. Okay, so let's take a look at using those. If I want to rewrite tangent to the 4th x in terms of first powers of cosines, the first thing I would want to do is I would want to go ahead and factor it into tangent squared x times tangent squared x. So, and this is going to be 1 minus cosine of 2x over 1 plus cosine of 2x. And it would be multiplied times itself, right? So it's going to be this item squared, which if I simplify will be 1 minus 2 cosine of 2x plus cosine squared 2x over 1 plus 2 cosine 2x plus cosine squared 2x. So now we'd want to go back and look at the power reducing formulas again, only this time we want to reduce cosine squared. So let's go ahead and bring this out. And what I'm going to want to do is I'm going to want to go ahead and put this up in place of my cosine squared in each case. So I'll have 1 minus 2 cosine 2x plus 1 plus cosine of 2 times u. Now u in this case was 2x, so it would be cosine, 4x divided by 2. And in the denominator, I'll have the same. I'll have 1 plus 2 cosine 2x plus 1 plus cosine 4x over 2. Okay, so if we went ahead and distributed the division here, then we're going to have 1 minus 2 cosine 2x plus 1/2 plus cosine 4x, or actually we'd say 1/2 cosine 4x. And I'd simplify to get the same over here. And we could combine the 1 and the 1/2 if we wanted to, but this is now there. We wanted first powers of cosines, and that's what we've got. If I want to make this a little bit simpler, I could also factor out a 1/2 out of each of the terms. And in fact, that would be much simpler because the 1/2 will cancel. So if I factor a 1/2 out of this, remember I had 1 and 1/2, that would be 3/2, so that would become 3 minus 4 cosine 2x, we already took care of that, plus cosine 4x. And in the denominator, we'd have the 1/2. So we'd have 3 plus 4 cosine 2x plus cosine 4x. And then the 1/2s will cancel. Okay, so this is the final and most simplified form. So if we take a look at using the half angle formulas are up here. So we've got half angle formulas for sine, cosine, and tangent again. And then if we look at using those, if we want to find the exact value of the cosine of 105, then I could say that's going to be the cosine of 210 degrees over 2. And I say 210 because 210 is a common angle. It's 180 plus 30. Right? That's 210 degrees. And I know that its cosine is related to the x-coordinate that would be here. Right? And the x-coordinate here would be, for 210, cosine is negative radical 3 over 2. And I'm taking that information from the unit circle. So the cosine of 210 divided by 2 is going to be plus or minus the square root of 1 plus the cosine of u, which would be negative radical 3 over 2, all divided by 2. So that would be plus or minus the square root of 1/2 plus, I'm sorry, not plus, minus, because that's negative, minus radical 3 over 4. And all I did was I distributed the division of the 2. Let me rewrite that 1/2 so it's legible. Right, and then we could actually work this out to be a decimal and figure out its value. So if we want to take a look at something like this, finding all the solutions of cosine squared x equals sine squared of x over 2. So if I look at the sine squared of u over 2, that's going to be plus or minus the square root of 1 minus cosine of x divided by 2 squared. So I'm just going to get 1 minus cosine x over 2 equals cosine squared x. If I multiply both sides by 2, I'll get rid of that. And then if I want to go ahead and add cosine of x to either side, equals 1. And over here then we'll get, if I factor a cosine out of each of these, of cosine x times 2 cosine x plus 1. No. That's not what I wanted. And if now I set this to be equal to 0, I'm going to subtract 1. I'll have 2 cosine squared x plus cosine of x minus 1 equals 0. If I factor this, I'm going to have 2 cosine x minus 1 times cosine of x plus 1 equals 0. And if I set them each to be equal to 0, I'll have cosine of x is equal to negative 1. So in this case, where cosine is negative 1, that's at pi. And I'll have 2 cosine of x minus 1 equals 0. So that would be actually cosine of x equals 1/2. And where cosine equals 1/2, that would be here and here. So again, we're talking about pi over 3 and 5 pi over 3. Okay. And we also have product to sum formulas. So if we have two different, the sines being multiplied together, cosines being multiplied together, sine times cosine, cosine times sine, and different ways that we can simplify. So if we take a look at this, I have sine times cosine. So sine times cosine, that's going to simplify to be 1/2 times the sine of 5x plus 3x plus the sine of 5x minus 3x. So it's going to be 1/2 of sine 5x plus 3x would be 8x plus sine of 2x. So we also have sum to product formulas. So we can have sine plus sine, sine minus sine, cosine plus cosine, or cosine minus cosine. And that will allow us again to simplify in other ways. So let's take a look at using those. If I want to find the exact value of these two, so I'm looking at sine plus sine, that's going to be 2 times the sine of 195 plus 105 over 2 times the cosine of 195 minus 105 over 2. So this becomes 2 times the sine of 195 and 105 is 295 300 divided by 2 times the cosine of 195 minus 105 is 90 over 2 So this is 2 times the sine of 150 times the cosine of 45. Okay, well, cosine of 45 is radical 2 over 2. Sine of 150, remember 150 is over here. We're talking about the x-coordinate. That's radical 3 over 2. So 2 times the sine of, I'm sorry, not sine of 1 radical 3 over 2. It just is radical 3 over 2 times radical 2 over 2. So we'll have 2, the 2's will cancel, and I'll have radical 3 times radical 2, which is radical 6 over 2. Okay, if we wanted to look at one of the difference formulas here, we can go ahead and use this. We'll have 2 times the cosine of 4x plus 2x over 2 times the sine of 4x minus 2x over 2. So this will be 2 times the cosine of 6x over 2, which would be 3x, times the sine of 4x minus 2x is 2x divided by 2, which would just be x. So now if I set 2 cosine 3x equal to 0, and I also set sine of x equal to 0. Well, where is sine 0? That's at 0 and at pi. When we look at 2 cosine of 3x, when we divide by 2, we'll have cosine of 3 times x equal to 0. So then the angle that would equal 0 for cosine, that would be the x-coordinates being 0, that would be 90, right? So 3x would be equal to 90 degrees, or actually pi over 2. And 3x would also be 3 pi over 2. So if we divide by 3, this would be pi over 6, and this would be pi over 2. Okay, so then these would be our solutions. All right, now the last thing we're going to work on here is projectile motion. Now, if I take a look at this item, they want me to rewrite this in a simpler form. And you see that if I examine the double angle formula, I could get rid of the cosine if I could write this as a double angle. Right? If I could convert this back into that, if I just had the 2 here. So if I factor a 2 out of 1/16, then I'll get 1/32. Velocity sub 0 squared times 2 sine of theta cosine of theta, and that's going to become sine of 2u. So if I simplify this, this just becomes sine of 2 theta. Okay, so that's simpler, got rid of the cosine. That's where we want it to get to. Now, the next part of the problem, they want me to figure out what angle should the player kick the football so it'll go 200 feet. So if I say, and we also need to know a little bit more about this, he's kicking with an initial velocity of 80 feet per second. Okay, so actually I should have gone ahead and put that in here. I'll simplify it over here. So if I want it to travel 200 feet, my initial velocity was 80 squared times the sine of 2 theta. So if I continue to simplify this, my 200 feet will equal 1 over 32 times 80 squared. Well, 80 squared is 6,400. So this will become 6,400 over 32 times the sine of 2 pi. We see 32 goes into 64, 100 200 times. If I divide both sides by 200, I'll have 1 is equal to sine of 2 times theta. So where does sine equal 1? Well, sine equals 1 up here at 90 degrees. So I know that the sine of 2 theta is equal to 1. That means that 2 theta is equal to 90 degrees. So theta is equal to 45 degrees. So this is the angle he needs to kick at in order to get the ball to go 200 feet. So to sum this up, we've gone through the lot of formulas: double angle formulas, power reducing formulas, half angle formulas, product to sum and sum to product formulas, and we went ahead and worked with a real life model. And that's it for chapter 3.